Hi again, guys. Let's talk more about chapter 19. So remember yesterday or whenever you last watched the video, we were working on number 12, page 447, and for part A, it asked us to find the margin of error. But this time, let's actually find the confidence interval. But remember this number, okay, that we calculated, the margin of error. So let's find the 95% confidence interval. Okay. Now remember, we were given a few things. We were given that p hat equals 0.08 or 8%. And let's actually keep that as a percentage. So 8%. And we know that n was 1,012. And then our calculations, our margin of error was 1.7%. Okay? So keep in mind that the formula for confidence interval is estimate plus or minus the margin of error. Okay? The way your formula sheet has it, it says statistic plus or minus the critical value times the standard error of the statistic. Okay, and I'll show you where that's at in your formula sheet. Right on the bottom, right there. So write that down, chapter 19, confidence intervals. And we're going to be dealing with this for the rest of the school year as well. Okay. So now the statistic, if you guys remember to our discussion last week, remember there's a parameter and there's a statistic. A parameter deals with a population, a statistic deals with a sample. So what statistic did we deal with in this problem right here? It was the p hat, the 8%. Okay. The critical value, remember, the critical value is tied to your confidence interval. So our confidence level. Our confidence level here is 95%. So our critical value is, for this one, 1.96. And then the standard error was that formula, right? S equals p hat q hat over n. But you know, we already calculated all of this, right? We already calculated this, and our margin of error is this answer right here. And this answer is 8%, right? It's 8% plus or minus, we already did this earlier, 1.7%. So our confidence interval, you can write it like this, and I'm going to rewrite it on the other page. So confidence interval, the 95% confidence interval is 8% plus or minus 1.7%. So this is how much we would be off by. So if you illustrate this, 8% would be in the middle, and you're off by 1.7% above, 1.7% below. So you can calculate this as 6.3% to 9.7%. So you are 95% confident that the proportion, the true proportion, will be between these two values. So if you look at your sentence frame, right here, again, these are in the back if you want to grab another one. You can use either of these two right here. It's saying the same thing. Okay, so I'm going to write that out for you. When the question asks you to interpret something in context, this is what it means. I think, let's see, let's find the problem. Yeah, so for example, you're going to do, if you haven't done it already, you're going to do number 23 in your homework. And if you look at part C right here, it says interpret your interval. This is what you're going to do. Right. So I am 95% confident that the true proportion of adults who, what was it again? Who approve attempts to clone a human is between, and this is where you list your interval, between 6.3% to 9.7%. Okay? So remember, what we're trying to do with confidence intervals is we're trying to infer something about the population based off of our sample. So we don't know what the population parameter is. We don't know actually what percent of adults approve of attempts to clone a human. But we have this sample. Remember, we had a sample of 1,012 adults. So based off of this sample, what can we say about the entire population? Well, we can say that the true proportion, which represents the population proportion, is going to be somewhere between this. How sure are we of this? We are that % sure. Okay? So just back to confidence intervals. You guys remember our old friend, the normal curve? Oh my gosh, that's bad. But remember, this is 68% is 1 standard deviation. 2 standard deviations is 95%. And 3 standard deviations is pretty much almost 100%, 99.7%, right? You guys remember this. So if we're to find the critical values of this, and for this one right here, okay, we would have to figure out what percent is in this side and what percent in this side. So 100 minus 68 is 34. So the total of these two sides is 34. So that means we're looking at an area of 0.17. So if you do inverse norm of 0.17, that'll give you the critical value for a confidence level of 68%. Okay, you guys remember, as your confidence level increases, so does the size of your interval. As your confidence decreases, so does your interval. All right. Some of you may be wondering about conditions and assumptions. Okay, this is same as chapter 18. So confidence intervals, nothing changed. If it's a proportion, which is what we're doing right now, it's going to be SIR10. If it's a mean, which we'll do later, it's going to be NIR10. And this is on page 438 for proportion. So check it out right there. It's exactly the same, nothing's different. Okay, so let's try number 17, and I want to just do 17A. This is on page 447. Let's actually construct a 95% confidence interval. So go ahead and take a pause the video and read to yourself what number 17 is about. Okay, and then you should get your P hat, your Q hat, and your N. Okay, so they're asking this question about how people feel about the death penalty, if it's fairly applied, and they changed the wording of the question. And they found that P hat out of a sample of 538 respondents, that proportion of the people actually said they thought the penalty was fairly applied. Okay, so we want to make, it says construct a 95% confidence interval. So let's think back to what we just did in the previous one, right? We're gonna do the same thing here. We're really working on this part of it, okay? So the formula is p hat plus or minus the critical value times the standard error of our p hat. So we know our p hat is 0.44. We know our critical value for 95% is 1.96. Remember, if you forgot what this is, you can calculate it using inverse norm. Okay, but I'm pretty sure you'll memorize it from now on. And this one is the p hat. It's on your formula sheet. P hat times q hat all over n in the square root. All of it over in the square root. So this would be 0.44 times 0.56 over 538. Okay. So this is 0.44 plus or minus 1.96 times 0.02140076. I'm just gonna keep the digits right there. And 0.44 plus or minus, you multiply that out, you get 4.19454913. Okay. So what do we just do? What is that number right there? That represents our margin of error. Because remember, this calculated, that is our margin of error. How much we're going to plus or minus from our statistic, our estimate. Oops. I put that decimal in the wrong place right there. That should be like that. So if we can leave our answer like this, or you can say it's from 0.398 to 0.482. Okay, so this would be our 95% confidence interval. All right. So to interpret this, you would use that sentence frame from our formula from our sentence frame sheet. I am 95% confident that the true proportion of respondents who think the death penalty is applied fairly based on the question is between this number and that number. All right? So now here's the moment you've been waiting for. How to do this on, so this was by hand. Okay? So how do we do confidence interval by your TI? And then we'll need to go in our textbook to page 440. Okay? So grab your calculators. Oops. We're gonna go to stat. And then we've never gone to this column now. We're gonna go to tests. And then you're gonna scroll. On my calculator, it's option A, but this might be different for your calculator. So one that says 1 prop Z interval. Okay. So what this means is we're using one proportion. Believe it or not, later on we're gonna use two proportions. Z, right, Z critical value, and this int stands for interval. If you scroll down that list, you'll see things called tests, and we'll work on hypotheses tests next chapter in chapter 20. Okay, so when you go here, they ask you for an X, an N, and a C level. Okay, and C level you already know is the 95%, so the 0.95. You know the N is 538. Okay. However, you don't know the X. They don't give you anywhere. It is not 0.44. 0.44 is your p hat, okay? So what they want you to calculate, really, for this question is, what is 0.44 times 538? What is 44% of your sample, 538? Okay, so in your calculator, if you put this in, 0.44 times 538, okay, you get a number of 236.72. Okay, so now all you gotta do, put that in, hit enter, and you get, I think it says something like error or something like that. So they won't take a decimal right here. When I say they, I mean the calculator. It has to be a whole number. So you got choices. You can round this up or you can round this down. So since we're talking about people here, we're talking about respondents, we didn't get a whole person here. So I'm gonna go ahead and just round this down because I know there's at least 236, okay? So I'm gonna go back to stat, calc, A, and I'm gonna do 236. Can you see that? Should look like this. And I'm gonna calculate. Voila, wow. So you notice your p-hat is in there. Your p-hat is a little bit different from the one in the given information. It's because we rounded it, okay? So now your confidence interval goes from 0.39673 to 0.48059. And how does that compare to our previous one? Pretty close, right? Pretty close. Again, with rounding, their answer changed a little bit. Okay? So that's how you do it on your calculator. Please try that. Oh, this is part A. Okay, and then part B just asks the question for number 17. Recall that 53%. Now they're basically asking, is 53% in this range, right? So back to this one right here. If this is 0.44, this is your p-hats. Okay. With the margin of error of what? 0.0419, etc. This goes to 0.482, 0.398. They're asking, is 0.53, like, is that within your interval? Of course not, right? So that's a no. So part B is simply no. Okay, so that's it. Let me know if you have any more questions, okay? Thanks. Do your homework, please. Get off your cell phone. Stop playing computer games right now. Stop reading that World and Me book for your English class. Do your homework right now, please.